Hey everyone, welcome back to Byju's class 8, 9 and 10. I can see Abhijit is here, Yasharth is here. Good evening, good evening. Hi, hello. Hey Diksha. Hi Bapya. Hey Manjot. Good evening Abhinav. Hi Utkarsh. Life for country. Jai Hind man. Jai Hind, life for country. Hi Amal. Hey Dhruv. Hi Fenil. I'm doing well, thank you. I hope you all are safe. I hope you're doing great. Yes? Awesome. Most of you were there yesterday as well. So, yesterday we covered periodic classification of elements in one single shot, in one shot, right? And you really wanted us to come up with interesting questions, right? So, we are here with interesting, hypothetical, critical, theoretical, all sorts of questions only for you people. So, yes, we do read your comments. So, whatever you need from us, you can type, and we will definitely make sure that that happens. Food evening. Okay. Someone's really hungry right now. Good evening, good evening. Alright, so this session is completely as per your demand. We're going to cover critical questions. So let me just put a star over here. All important questions. Hi Vaibhav. Hey Divya. Nice. Alright, but before we begin, before we kickstart with today's session, I want all of you to confirm if this setup is working fine. So am I perfectly audible and visible? And check the PPT as well. Give me some critical emoji. Okay, something different. Don't give me a thumbs up. We're gonna solve critical questions, so come up with nice emojis, na? Yes? Thank you, Abhinav. Oh, I see star, I see books. I see a nerd face, not bad. Hi, Rashmi Rekha. Alright, so I get interesting emojis. Fire. 100%. Flowers, nice. Awesome. So I hope everything is working fine. If not, you can let me know right now so that we don't face any technical issue during the session. Great, Utkarsh, I can see that. Absolutely. Hi, Rita. Hi, Animesh. Great, I think we are good to go. Everything seems fine. Full of energy, absolutely. Yashat says, let's get started. Okay, let's listen to him and just put on your thinking caps because we are going to solve some amazing questions together. Ready? Awesome. Alright, chalo. Let's see what's the first question. So, be ready. If you know the answer, you can always post it in the comment section. Okay, so I'm going to read your answers from here. Right here in front of me, there's a chat box open and I'm going to read your answers. In case you're not able to solve the question, not a problem. That's why we are here. We're going to solve it together then. No, Divya, not at all. Alright, Suryansh is saying I'm absolutely ready. Chalo, let's start then. Okay, this is the first question that we have. Mendeleev predicted the existence of certain elements that were not known at that time, right? Yesterday we actually studied about this, right? And he named two of them as Eka aluminium and Eka silicon. Now, A part of the question says we need to name these elements. What is Eka aluminium and what is Eka silicon? And the B part says what is the formula of oxides and hydrides formed by these elements. So let's break this question into small chunks and solve it one by one. So this part carries 1 mark, this part carries 2 marks. Let's start with the first part. Here we have to name the elements which have taken the place of Eka aluminium and Eka silicon. I can see you people have started writing answers. Gallium, germanium, Disha says. Ayush is also saying the same. Alright. Nice. Yes. So basically, Eka, this term, is a Sanskrit term, right? It means one or first. Awesome. It means one or first. And when I say aluminium, what does it mean? It means that first I've got aluminium, and then just below aluminium it's going to be this new element, that is aluminium. Silicon means first silicon is there, and just below silicon it's going to be silicon. That is the element that was yet to be discovered, the predicted one, right? Now let's look at this table. This is Mendeleev's table. Over here, let's find out where is aluminium, where is silicon. Let's magnify and see. There you go. It's right there. Now, aluminium is in group 3, silicon is in group 4. Later on, when they tried to find out the properties, they have named these elements as gallium and germanium. As most of you have answered, well done, Weber, you're absolutely right. Yes. Gallium is the actual name of this element, which was earlier known as aluminium. Similarly, germanium was earlier known as silicon. Now, the actual and predicted properties are on the same page. They're very similar. May it be atomic mass, so near, isn't it? May it be formula of oxide. It's E2O3. For gallium, it's Ga2O3. For chloride, it's ECl3. For gallium, it's GaCl3. Similarly for germanium. So yes, his prediction was very much right. And as he told us not to call it defect, so we are not going to call this as defect, we're going to call it as gaps. And these gaps were perfectly filled later on. So, gallium and germanium have taken the place of aluminium and silicon in the modern periodic table. And there you go, that's your answer. So, you have to mention gallium and germanium. And this carries half mark for gallium, half mark for germanium. Now, earlier you used to solve questions. You would know, okay, this is a 1 marker, this is a 3 marker. Now we are telling you the distribution as well. This will help you prepare better. So half mark is for gallium, half mark is for germanium. If you mention this, you are definitely going to get full marks. Alright, now let's move on to the B part. What is the formula of oxides and hydrides formed by these elements? Let's go back to the periodic table, Mendeleev's periodic table. Mendeleev's version of periodic table. Okay, now over here, you see gallium is here in group 3, germanium is here in group 4. Alright, let's zoom and highlight the general formula of oxides and hydrides. You remember we've taken oxygen and hydrogen as the standard element, right? We took both of them as the standard elements. And then we made all other elements to be reacting with these two standard elements. For gallium over here, the general formula is going to be the one which is applicable for group 3, that is R2O3, where R is your element. And for hydride, it's RH3. All you need to do is write the symbol of gallium in place of R. So this becomes Ga2O3 and GaH3. Yes, Bhagya, absolutely right. Diksha, well done. Thank you, Deepak. Great, Vaibhav. Hey, Vaibhav, you might want to cross-check once. Okay, now, similarly for germanium. Okay, I think, Vaibhav, you were answering for germanium. Alright, then that's right. For germanium, you've got over here group 4. And this is the general formula, RO2 and RH4. In place of R, we are going to write the element symbol now. So, it's GeO2 and GeH4. Yes. So in the exam, how you have to present this answer? Have a look over here. This is how you're going to present your answer. The respective formula of oxide and hydride by gallium is this. So half plus half, 1 mark. Next, similarly, you're going to write for germanium. GeO2 and GeH4. Half plus half, 1. And this is how your answer sheet should look like. Awesome. If it's a Mendeleev based question, then yes, of course. Alright, let's move on to the next question now. In this question, if you know the answer, you can directly write the answer in the comment section. Consider the given set of elements. They've given us lithium, potassium, magnesium, carbon, hydrogen, sulfur and nitrogen. We have to identify the most metallic element, elements that form acidic oxides, and most electronegative element. And this question is of 3 marks. We're going to tell you how these 3 marks are being bifurcated. Yes, easy peasy. Chalo, let's solve this mystery. Let's see. First of all, we're going to solve the A part. That is, we need to figure out the most metallic element. Now, metals, they show metallic nature, right? More the tendency to lose electrons, more will be the metallic character. Simple. Now, all you need to figure out is the trend of this metallic character. Over here, as you go across a period, as you go from left to right, metallic character decreases. And I told you a hint, I gave you a hint also to remember this. So on the left side, you've got metals, on the right side, you've got non-metals. Of course, across a period, metallic character is decreasing. Electrons are being added to the same shell. What is happening to the effective nuclear charge? That's increasing. If the force of attraction is increasing, electrons will be held tightly, right? And it's going to be difficult to lose them. But what happens down the group? Metallic character increases because now the electrons are being added to the next shell. The effective nuclear charge is decreasing. And it's easy to lose electrons then, right? Because they're not being held very tightly. I can see Fenil, Nasreen, Padmali, you people have already answered as potassium. Shiva says it's lithium. Vaibhav says it's potassium. Divya says it's lithium. Shubha says it can be magnesium also. Okay. First of all, out of these given options, potassium over here is your answer. Let's figure out. I'll tell you how to eliminate the wrong ones. You can rule out carbon, sulfur, nitrogen, right? Because obviously they're on the right side, non-metals. Now you're left with lithium, potassium, magnesium and hydrogen. Have a look over here. Down the group, metallic character increases. And this helps us to find that potassium is the correct answer. Now for the ones who were saying it's lithium, maybe you were just taking into account this factor. Left to right metallic character decreases, so left will be the most metallic. But you also have to take into account what is happening down the group. I hope you found your mistake. Yes, give me a thumbs up if you found your mistake. Chalo, let's move on to the next one now. This is how you need to present your answer. You will write from the given set of elements, potassium is the one that is going to be most metallic. And by doing that, you will get full marks. Over here, this full marks is just 1 mark. But yes, every mark is important, right? So, the next part of the question says, elements that form acidic oxides. Hey, we did this yesterday as well, right? Basic oxides, acidic oxides. So, generally, metals form basic oxides. And non-metals form acidic oxides. Again, you just need to remember where are metals being placed, where are non-metals being placed. You've got metals that side, right? On the left side. So as you go from left to right, metallic character is decreasing. So what is going to happen to the basic nature of oxides? Basic nature of oxide will also decrease, while acidic nature is increasing. And down the group, there is no change in the nature of oxides. Now, what are we concerned with? We are concerned with acidic oxides. Alright, I can see Bantna writing about carbon, sulfur, nitrogen. Disha is also saying the same answer. Hey Divya, don't be scared. Rajbir is also saying the same. Fenil is also saying, okay, Fenil is saying sulfur only. Sulfur is correct, but let's think of others also. Alright, over here, carbon, nitrogen and sulfur, they are going to form acidic oxides. So people have guessed it right. Absolutely right. Rest of them you'll find on the left side, on the metallic side, right? They are forming mostly basic oxides. We are concerned with acidic oxides. Yes, nitrogen is right, Abhinav. Alright. Carbon, nitrogen and sulfur. That's the correct answer. And that's all that you need to mention in the exam, right? This is what you need to mention, that carbon, nitrogen and sulfur, they form acidic oxides. And by doing that, you're going to get full marks. That is, you will score 1 mark by writing this. Yes. So that's why, Vanna, that's why the term generally is there. Because we do have neutral oxides. Yes. True. Chemistry is full of exceptions, absolutely. So we very conveniently, keep saying generally, usually. But yes, there are exceptions. Alright. Chalo. Now, let's see what's the next part. Here, you have to find out the most electronegative element. You people have understood the concept really well. You people are writing all the answers over there. So let's see who's going to get this one right first. Now, when we talk about electronegativity, it's the tendency of an atom to attract the shared pair of electrons towards itself, right? As you go from left to right across a period, electronegativity increases. And what happens to electronegativity down the group? It decreases. Connected with the effective nuclear charge. Left to right, effective nuclear charge is increasing, right? If the effective nuclear charge is increasing, it's going to attract electrons, more and more electrons, right? Electronegativity is definitely going to increase. Okay, Divya says sulfur. Abu Tahir says sulfur. Abhinav says nitrogen and sulfur. Okay. Rethink, and I'm going to give you a hint. You people are applying the concept of what is happening across a period. You also have to apply the concept of what is happening down the group. Now, think about it again. Shreya says chlorine. Chlorine is not there in this given set of elements. Akshat says carbon. Pratiksha says carbon. Well, the correct answer is nitrogen. I can say Abhinav said nitrogen. Ashish also said nitrogen. Charvi said nitrogen. But many of you were confused between sulfur and carbon. So, let me explain you this one. Why lithium is not there, you all know. Let's leave the metals, okay? Let's leave everything that's on the left side. We are just concerned over here. Let me underline these. Carbon, sulfur, nitrogen. This is where you're getting confused, right? Compare carbon and nitrogen first. Left to right, electronegativity increases. So out of carbon and nitrogen, which element is going to be more electronegative? It's going to be nitrogen. Also, down the group, what is happening to electronegativity? It decreases. So now if I compare nitrogen and sulfur, sulfur will be less electronegative as compared to nitrogen. So this makes nitrogen as the most electronegative elements out of this given set of elements. Yes, Vaibhav, absolutely right. Yes, Shreya. Hey, it's good that you found your mistake. That's the entire purpose of this session. If you will know how to read the periodic table properly, well, I think half of your task is done there only. Divya finds this question to be good. Yes, all questions are amazing, Divya. Alright, so what do you have to write? During the exam, you just have to mention that nitrogen is the most electronegative element from this given set of elements. And there you go, you're going to get full marks in this question as well. And with this, we are done with this question. Let's move on to the next question. Let's see. This is another very interesting question. If you've understood the trend, you will be able to answer this one. Great. Chalo. The diagram below shows the first 3 periods of the modern periodic table. Okay, they've given us 3 periods over here. 5 elements have been represented by the letters P, Q, R and T, which are not their chemical symbol. Okay, so P is not phosphorus. Randomly, they've taken some letters to represent these elements. What do we have to do? We have to identify the type of bond which is formed between P and Q, identify the element with the largest atomic radius, and the least reactive element. Cool. Great. Let's begin. Alright, let's start. Let's start with the first part. Identify the type of bond formed between P and Q. Where is P? It's over here. Where is Q? It's over here. Hey, recall how a covalent bond is being formed. It's formed when 2 non-metals are basically reacting. They are sharing electrons, right? Now, P and Q that you have over here, they both are non-metals. So, they are going to form covalent bond. They're going to share the electron, right? So, by sharing of the electrons, they're going to form covalent bond. Kashish, you're absolutely right. Charvi, well done. Hey, Divya, It's not going to be ionic. Group 14, carbon family. And group 17, halogens. Yes. Absolutely. So, what do you have to mention in the exam? You have to mention that the type of bond formed between P and Q is going to be covalent. Well, I hope this question was easy to understand for all of you. Great. Thumbs up. I'm getting thumbs up over here. Yes, gaming gangster. Keshvi says yes. All right. Chalo. Next part of the question says identify the element with the largest atomic radius. Largest atomic radius. Look at these very, very carefully. Okay. You have to take into account both the things across a period, down the group. Both the trends, okay, need to be taken care of. Over here, we are talking about largest atomic radius, which is nothing but the size, right? Now, atomic radius, that is the size of an atom. It's the distance between the center of the nucleus and the outermost shell. Abu Tahir, Fenil, Krish, Ashish, these guys have already answered. Deepak, Aryan says E. E is not there, Aryan. It's some typing error. Rajbir says R. Most of you have said R. Okay, Divyansh is saying this R is magnesium. He's going one step ahead. Okay. R. Most of you are saying R. Weber is saying T. Okay. Niljoy says R. Rajbir says R. Okay, let's see. As you go across a period, what happens? Atomic radius decreases. Why is this happening? When you go across a period, what is happening? Your effective nuclear charge is increasing. Now, if the force of attraction is increasing, electrons will be held tightly, right? It's going to be attracted more, so size is going to decrease. But down the group, when we go, effective nuclear charge decreases. Electrons are being added to the next shell, right? And because of this, your size goes on increasing. So obviously, the correct answer, as you people have guessed it right, is R. And this makes me really happy. This means that you people have understood the concept. Yashad is saying R, magnesium has the largest atomic radius. Hey, all of you have written R. That's great. Yes, Akshat. Absolutely. Well said. Nice. True. R. Okay. Ashish is saying R for right. Yes, that's the right answer. And that's all you need to mention in the exam if this question comes, that R has the largest radius among the given set of elements. And this, by mentioning this, 1 mark will be allotted to you. Yes? Awesome. Yeah, there's a purpose we are telling you the bifurcation of marks. This will help you prepare better. You would know how basically, say there's a 3 marker, there's a 5 marker, how these questions are being actually divided. And yes, every part is important. Every part is going to contribute. It's very important. If they ask you to give reason, then of course you have to. Alright, now, we also have to identify the least reactive element. Which is the least reactive element? Well, this is no rocket science. This is a very basic one. Everyone is trying to be like noble gases, right? To have a noble configuration, to have a stable configuration. And why is that? Because they have no tendency to lose or gain electrons. They're already stable. They're already happy. Aur kya chahiye? And this stat box is full of element T. Awesome, guys. You people are so quick in answering. Kashish is saying I answered first. Sia, Aditi, Amal, all of you have answered T. Absolutely true. So, the correct answer is T. T is going to be least reactive. Hey, by the way, which noble gas are we talking about? You can write this in the comment section. So, out of this given set of elements, T is the least reactive, and by mentioning this, you will gain 1 mark. Absolutely. From the exam point of view, this is what you need to mention. Argon. Awesome, guys. Chalo, let's move on to the next question that we have. You people have performed really well till now. In fact, I am getting more and more confident in your performance. Yes. Thank you. Alright, let's see what the next question is. Compare the following elements as per the characteristics given in the brackets. Okay. Magnesium and phosphorus based on atomic radius. Lithium and fluorine based on electronegativity. Boron and aluminium based on valency. And this question is of 3 marks. Let's start with the first one. Magnesium and phosphorus. Where is magnesium? It's here. Where is phosphorus? It's here. From left to right, what is happening? Atomic number is increasing. Number of protons and electrons both are increasing. Now, you see the atomic number that is increasing. You see the proton number increasing, electron number increasing. But hey, the effect of the increase of proton number is way more than that of electron number. That is why effectively the nuclear charge is increasing across a period. And because of this, what's going to happen? Electrons will be held really tightly. The bonding is going to be so strong and the size will keep on decreasing. So, atomic radius, that is your size of the atom, will decrease. So, magnesium is going to have a larger radius as compared to phosphorus. Bandana said magnesium is going to have more radius. Fenil is saying the same. Aryan is saying the same. Abu Tahir, Smita, Kamal. Yes, Kamal, I just explained the same. Awesome, guys. Yes, magnesium is going to have a larger atomic radius. Size of magnesium atom is going to be more. Alright, so this is all you need to mention in the exam, that magnesium has a larger atomic radius. But you know the reason as well, right? And with this, you're going to get 1 mark. Alright, I hope this question is clear to all. Let's move on to the next part. What's the next part? Lithium and fluorine. Which is going to be more electronegative? And they've already given you that left to right across a period, effective nuclear charge is increasing. We just discussed that, right? So lithium is there on the extreme left. Fluorine is there on the extreme right. Fenil says fluorine. Bhagyavardhan says fluorine. Deepak says fluorine. Bandana is also saying fluorine. Divya is also saying fluorine. Akshat, Nikesh, Pratiksha, all of you are saying fluorine. Well, from left to right, effective nuclear charge is increasing. Electronegativity is also increasing, right? And this makes fluorine as the most electronegative element over here. Shreya, Abhinav, Ashish, Ayush, all of you are right. Kashish, absolutely. Amal, Vaibhav, Aditi. Great, guys. You people have understood the trends thoroughly. You people were really attentive in the class yesterday. That means. Awesome. Well done. Yes, Shivansh, the correct answer is fluorine. Otherwise also, like, you can cross-check. Lithium is a metal, right? Fluorine is right there as a non-metal. If you're comparing these two. Yes. Cakewalk, absolutely. That's what happens when you start understanding chemistry. You will start finding all these questions very interesting. Alright, coming to the marking scheme, you're going to write fluorine is more electronegative than lithium. And this is how your answer sheet should look like. And with this, we are done with this part. Let's move on to the next one. Now what do we have to compare? We have to compare boron and aluminium based on valency. Based on valency. Fenil says boron has a valency of 3. Aluminium also has a valency of 3. Okay. Anybody else? You're welcome, Kamal. Alright, anybody else? Let's see. Well, the mystery part is over when you can see the table right there, right? Same, Akshat says same. Krish is also saying the same answer. Same. Okay. First, to understand valency, we should know about valence electrons, right? These are the valence electrons being given to you from left to right for all the groups mentioned over here. Now, clearly, if the number of valence electron is going to be the same, valency will also be same. For boron and aluminium, the atomic number for boron is 5. Atomic number for aluminium is 13. You see 3 valence electrons in case of boron. You see 3 valence electron in case of aluminium. And their valency is also 3. So valency of both aluminium and boron is the same. That is, it is 3. I really don't have to correct you people because you are giving all the correct answers today. I mean, I look at this chat box and I see a series of correct answers. Yes, absolutely. Can this day get any better? Yes, same valency. नहीं, phenyl मार नहीं पड़ेगी, बिल्कुल सही आंसर है. 3. 3 is the valency. So based on the valence electron, you can easily figure out the valency. Alright, so what do you have to mention in the exam? You have to mention that the valency of both boron and aluminium is the same. That is, it is 3. And by doing that, there you go. We are going to get 1 mark. Thank you, Sujata. Alright. Now, let's see what the next question is. Thank you, Vrishali. It's because you people are so attentive. Okay, come on. Get back to the class and solve this one. A metal X combines with oxygen to form a compound XO. Please note that we're talking about a metal X. The oxide XO is soluble in water and we need to figure out 3 things. How many electrons would be there in the outermost shell of this element X? To which group of the periodic table is this X being placed? And write the formula of the compound formed when this X is reacting with chlorine. Again, we're going to break this question into small chunks. We'll start with the first part. How many electrons would be there in the outermost shell of element X? Now, they are saying X is combining with oxygen to form XO. You remember in class 9th, they used to give us the elements. Okay. Then we used to see what the valence electron is, what the valency is. We used to crisscross and get to the chemical formula. Here, it's the inverted way that we are going to approach. We are being given the formula already. Okay. And we know X is a metal. Formula पहले उन्होंने दे दिया. O का symbol is for oxygen. Simple, sorted. Okay. And valency is 2. Now, for X, that's a metal, we don't know what the valency is. But, hey, look at this. It's XO. That means this is going to be 2. It's going to neutralize completely, right? It's going to cancel completely. So, this way, in the inverted way, we figured out the valency of X. That is 2. But the question doesn't end here. They are saying how many electrons would be there in the outermost shell of this element X. So, if the valency is 2 and if it's a metal, in that case, valence electrons are going to be 2 only. Yes, Vaibhav, Charvi, Nikesh, Bhagya, Keshvi, Barnasta, all of you are right. Awesome, guys. Well done. So what do you have to mention in this? That there are 2 valence electrons and you'll get 1 mark for this. That's okay, Kashish, not a problem. Yes, because it's a metal. So over here, valence electrons and valency is going to be the same. It's going to be 2 electrons. Papya, Tabriz, Akshat, you all are right. Chalo. Moving on to the next one. They are now asking to which group is this X belonging to. What do we know about X? We know it's soluble in water. What else? We know that oxides of only group 1 and group 2 are soluble in water, right? But we also know that group 1 has 1 valence electron. When you talk about group 2, elements are going to have 2 valence electrons. So the valency of group 1, if I write valency over here, that's going to be 1 for group 1 and 2 for group 2. And for XO, we know that the valency of X was 2. We know it in the last part, right? So clearly X belongs to group 2. Anchita, Sia, Fenil, Yashat, Nikesh, you all are right. Yes, the answer is again 2. But that was 2 valence electrons. This is group 2. Yes, Anchita. Yes, Nikita. Keshvi, Sujata. Great. So this is what you mentioned, that the element X belongs to group 2. Hey, what is this group known as? Divyansh has already answered. And by mentioning this group 2, there you go, you've just got 1 mark. See, that's how slowly, one by one, you're going to get full marks, right? Every part is important, absolutely. Every sub part of the question is really important. Okay, Chandrakala, noted. Chalo, let's move on to the third one. This is easy peasy. Write the formula of the compound formed when X reacts with chlorine. Now, this is a concept we've done in class 9. First, we write the symbol. X is there and chlorine. For chlorine, it's Cl. Next, we are going to write the valencies. We have figured out that X has a valency of 2. Chlorine, it's going to be 1. Why? What is the atomic number of chlorine? It is 17. So, 287 will be the configuration. And 7 valence electrons are there. Obviously, it needs 1 more to be stable. So, valency becomes 1. Now, what you have to do? You just have to crisscross and you will get the formula. Vaibhav, Kashish, Bhagya, Utkarsh, Divya, all of you are right. The correct answer is XCl2. Yes, Kashish. Yes, Fennel. Nice. Abu Tahir, Bandana, Sia, Keshvi, Ashish, Yasharth, Avinav. I'm sorry if I'm not able to read your name, but you people have nailed it today. You people got this one also right. Awesome. So the valency of chlorine is 1 and X is reacting with chlorine to form this compound XCl2. So this is going to be the final answer, and by explaining all this, you're going to get 1 mark. All right. So we are done with the session, but we're not done yet. There's a homework question for you. And this homework question you don't need to do right now. You have to do it after the class. So after the class, you're going to come back and write your answers in the comment section. The question says, given below is a part of the periodic table. Okay, so they've given you a part of the periodic table. As you go from left to right, that means across a period, what happens to electronegativity and why? What happens to effective nuclear charge and why? So don't forget to answer this why part also. You need to answer this question in detail, okay? So you're going to drop your answer in the comment box below after this class. Yes? So if you're going to do the homework, give me a thumbs up right now. Don't give me answers right now, give me a thumbs up right now. I'm going to check your answer later because I will also be needing this why part, okay? Alright. Yes, definitely we've got you covered. All you need to do is keep watching all these sessions that we've lined up for you people every Monday to Friday. We've got great sessions for you people, and now the upcoming session that's going to happen is going to be on 8th February. That's a Tuesday at 7 p.m. And what are we going to cover that day? We are going to cover carbon and its compound in one shot. So again, this is going to be a power pack class. Yes? Awesome. Will definitely be there. Yes, definitely. Obviously. Yes, we will be discussing that. Alright, there's also a link being given to you in the description box for a free trial class. I'm sure you must have taken it by now. If not, please go ahead and take this free trial class as well. Also, don't forget to like this video. Quickly, first like this video. And of course, share it with your friends so that you people can have great practice sessions together. And don't forget to subscribe. If you've done all 3, you can give me a thumbs up over here. And I'm going to restate the same point. I'm going to restate the main point, that is practice every day. Because, you know, if you really want to master anything, any subject, any topic, practice is going to be the best habit. Yes? Awesome. Yes, definitely. And that's why we are here. We'll make sure that you have good practice sessions with us. Thank you, Kashish. Well, I can see loads of thumbs up. Great. Awesome. Alright, chalo. I'll see you in the next class now. Until then, keep smiling, keep learning, and of course, keep practicing. Bye-bye.